So then, what is the origin story? Maybe the human side, but also the
Mhm.
technical side of Ethereum.
Sure. So I joined the Bitcoin community in 2011, and I started by just writing. I first wrote for this sort of online thing called Bitcoin Weekly. Then I started writing for Bitcoin Magazine. um, and
Sorry to interrupt. You have this
Sure.
funny kind of story, true or not, is that you were disillusioned by the downsides of centralized control from your experience with WoW, World of Warcraft. Is this true, or you're just being witty?
I mean, the event is true. The fact that that's the reason I do decentralization is witty.
Maybe just a small tangent. Have you always had a skepticism of centralized control? Is that
To
sort
some
of
degree, yeah.
has that feeling evolved over time, or has that just always been a core feeling that decentralized control is the future of human society?
And it's definitely been something that felt very attractive to me ever since I could have learned that such a thing is
It's
possible.
possible, even
Yeah.
technically. So great. So you joined the Bitcoin community in 2011. You said you began writing.
hmm
So what's next?
Started writing, moved from high school to university, halfway in between that, and spent a year in university. Then at the end of that year, I dropped out to do Bitcoin things full time. And this was a combination of continuing to write Bitcoin Magazine, but also increasingly work on software projects. And I traveled around the world for about 6 months and just going to different Bitcoin communities. Like I went to first in New Hampshire, then Spain, other European places, Israel, and then San Francisco. And along the way, I've met a lot of other people that are working on different Bitcoin projects. And when I was in Israel, there were some kind of very smart teams there that were working on ideas that people were starting to kind of call Bitcoin 2.0. So one of these was colored coins, which is basically saying that, hey, let's not just use the blockchain for Bitcoin, but let's also kind of issue other kinds of assets on it. And then there was a protocol called Mastercoin that supported issuing assets, but also supported many other things, like financial contracts, like domain name registration, and a lot of different things together. And I spent some time working with these teams, and I quickly kind of realized that this Mastercoin protocol could be improved by kind of generalizing it more, right? So the analogy I use is that the Mastercoin protocol was like the Swiss Army knife. You have 25 different transaction types for 25 different applications. But what I realized is that you could replace a bunch of them with things that are more general purpose. So one of them was that you could replace like three transaction types for three types of financial contracts with a generic transaction type for a financial contract that just lets you specify a mathematical formula for kind of how much money each side gets.
By the way, it's a small pause. What's you say financial contract? Just the terminology. What is a contract? What's a
That's
financial contract?
so this is just generally an agreement where kind of either one or two parties kind of put collateral kind of in, and then they, depending on kind of certain conditions, like this could involve prices of assets, this could involve the actions of the two parties, it could involve other things. But they kind of get kind of different amounts of assets out that just depend on things that happened.
So a contract is really a financial contract is at the core. It's the core interactive element of a financial system.
There's many different kinds of financial contracts. Like there's things like options where you kind of give someone the right to buy a thing that you have for some specific price for some period of time. There's contracts for difference where you basically are kind of making a bet that says like for every dollar this thing goes up, I'll give you $7, or for every dollar the thing goes down, you give me $7 or something like that.
But the
And
main idea that these contracts have to be enforced and trusted.
yes, exactly.
You have to trust that they will work out in a system where nobody can be trusted.
Yes. Mm.
This is such a beautiful, complicated system. Okay, so you were seeking to kind of generalize this basic framework of contracts.
hmm
So what does that entail? So what technically are the steps to creating Ethereum?
Sure. So I guess just to kind of continue a bit with this Mastercoin story.
Sure.
So started by kind of giving ideas for how to generalize the thing, and eventually, this turned into a much more kind of fully fledged proposal that just says, "Hey, how about you scrap all your features and instead you just put in this programming language?" And I gave this idea to them, and their response was something like, "Hey, this is great, but this seems complicated and this seems like something that's we're not going to be able to put onto our roadmap for a while." And my response to this was like, "Wait, do you not realize how revolutionary this is? Well, I'll just go do it myself." And then
What was the name of the programming language?
I just called it ultimate scripting.
Great.
So then I kind of went through a couple more rounds of iteration, and then the idea for Ethereum itself started to form. And the idea here is that you just have a blockchain where the core unit of the thing is what we call contracts. It's these kind of accounts that can hold assets, and that have their own internal memory, but that are controlled by a piece of code. And so if I send some ether to a contract, the only thing that can determine where that kind of ether, the currency inside Ethereum, kind of goes after that, is the code of that contract itself. And so basically, kind of sending assets to computer programs becomes this kind of paradigm for creating these kind of self-executing agreements.
Self-executing. It's so cool that code is sort of part of this contract. So that's what's meant by smart contracts.
Yeah.
So how hard was it to build this kind of thing?
Harder than expected. And originally, I actually thought that this would be a thing that I would kind of casually work on for a couple of months, publish, and then go back to university. Then I released it, and a bunch of people, or I released a white paper.
The white paper, the idea is there.
The white paper. A whole bunch of people came in offering to help. A huge number of people kind of expressed interest. And this was something I was totally not expecting. And then I kind of realized that this would be something that's kind of much bigger than I had ever thought that it would be. And then we started on this kind of much longer development slog of making something that kind of lives up to this kind of much higher level of expectations.
What are some of the... Is it fundamentally like software engineering challenges?
It was.
Is there social? Okay, so there's...
And social.
So what are the biggest interesting challenges that you've learned about human civilization and in software engineering through this process?
So I guess one of the challenges for me is that like I'm one of the kind of apparently unusual geeks who was kind of never treated with anything but kindness in school.
Yes.
And so when I got into crypto, I kind of expected everyone would just kind of be the same, kind of altruistic and nice in that same way. But the kind of the algorithm that I used for finding co-founders for this thing was not very good. It was kind of literally what computer scientists call the greedy algorithm. It's kind of the first 15 people who replied back offering to help kind of are the co-founders.
Oh, you mean like literally the people that will form to be the founders, co-founders of the community, the algorithm. I like how you call it the algorithm.
Yeah. And so what happened was that these like especially as the project got really big, like there started to be a lot of this kind of infighting, and there were a lot of like I wanted the thing to be a nonprofit, and some of them wanted to be a for-profit, and then there started to be people who were just kind of totally unable to work with each other. There were people that were kind of trying to get an advantage for themselves in a lot of different ways, and this just about 6 months later led to this big governance crisis. And then we kind of reshuffled leadership a bit. And then the project kept on going. Then 9 months later, there was another governance crisis. And then there was a third governance crisis. And so...
Is there a way to, if you're looking at the human side of things, is there a way to optimize this aspect of the cryptocurrency world? It seems that there is... From my perspective, there's a lot of different characters and personalities and egos. And like you said, I don't know if, I also like to think that most of the people in the world are well intentioned, but the way those intentions are realized may perhaps come off as
Yeah.
as negative. Like what is there a hopeful message here about creating a governance structure for cryptocurrency that where everyone gets along?
And after about 4 rounds of reshuffling, I think we've actually come up with something that seems to be pretty stable and happy. I think, I mean, I definitely do think that most people are well intentioned. I just think that like one of the reasons why I like decentralization is just because there's like this thing about power where power attracts people with egos, and so that just allows a very small percentage of people to just ruin so many things.
You think ego has a use? Like, is ego always bad? It seems like
It
some of
sometimes
us.
does. Within the Ethereum research team, I feel like we've found also kind of a lot of very good people that are just kind of primarily just interested in things for the technology, and things seem to just generally be going quite well.
Yeah, when the focus and the passion is in the tech. So that's the human side of things, but the technology side, like what have you learned? What have been the biggest challenges of bringing Ethereum to life on the technology side?
So I think first of all, just there's like the first law of software development, which is that when someone gives you a timetable, switch the unit of time to the next largest unit of time and add one.
Yes.
And like we basically fell victim to that. So instead of taking like 3 months, it ended up taking like 20 months to launch the thing. And that was just, I think, underestimating the sheer technical complexity of the thing. There were research challenges, like, so for example, one of the things that we've been saying from the start that we would do, one is a switch from a proof of work to a proof of stake, where proof of stake is this alternative consensus mechanism where instead of having to waste a lot of computing power on solving these mathematical puzzles that don't mean anything, you kind of prove that you have access to coins inside of the system, and this kind of gives you some level of participation in the consensus.
Can you maybe elaborate on that a little bit? I understand the idea of proof of work. I know that a lot of people say that the idea of proof of stake is really appealing. Can you maybe linger on it longer, explain what it is?
Sure. So basically, the idea is like if I kind of lock up 100 coins, then I turn that into a kind of quote virtual miner, and the system itself kind of automatically and randomly assigns that in a virtual miner the right to create blocks at particular intervals. And then if someone else has 200 coins and they lock those 200 coins, then they get a kind of twice as big virtual miner. They'll be able to create blocks twice as often. Right? So it tries to kind of do similar things to proof of work, except instead of the thing kind of rate limiting your participation being your ability to crank out solutions to kind of hash challenges, the thing that rate limits your participation is kind of how much coins you're kind of locking into this mechanism.
Okay, so interesting. So that limited participation doesn't require you to run a lot of compute. Does that mean that the richer you are, so rich people are more like their identity is more
Right, and this
stable,
yeah,
verifiable, or whatever the right terminology is.
right, and this is definitely a common critique. I think my usual answer to this is that like proof of work is even more of that kind of system.
Yes, exactly.
Yeah, 'cause-
I didn't mean it in that statement as a criticism. I think you're exactly right. That's equivalent. The proof of work is the same kind of thing, but in the proof of work, you have to also use physical resources.
Yes, and burn computers and burn trees and all of that stuff.
Is there a way to mess with the system of the proof of stake?
There is, but you will once again need to have a very large portion of all the coins that are locked in the system to do anything bad.
Got it. So, yeah, and just to that, maybe take a small tangent. One of the criticisms of cryptocurrency is the fact that I guess for the proof of work mechanism, you have to use so much energy in the world.
Yes.
is one of the motivations of proof of stake is to move away from this?
Definitely.
Like, what's your sense of the? Maybe I'm just underinformed. Is there like legitimately environmental impact from this?
Yeah. So the latest thing was that Bitcoin consumed as much energy as the country of Austria or something like that.
Yeah.
Yeah. And then Ethereum is like right now maybe only like half an order of magnitude smaller than Bitcoin.
I've heard you talk about Ethereum 2.0. So what's the dream of Ethereum 2.0? What's the status of proof of stake as the mechanism that Ethereum moves towards? And also, how do you move to a different mechanism of consensus
Sure.
within a cryptocurrency?
So Ethereum 2.0 is a collection of major upgrades that we've wanted to do to Ethereum for quite some time. The two big ones, one is proof of stake, and the other is what we call sharding. Sharding solves another problem with blockchains, which is scalability. And what sharding does is it basically says, instead of every participant in the network having to personally download and verify every transaction, every participant in the network only downloads and verifies a small portion of transactions. And then you kind of randomly distribute who gets how much work. And because of how the distribution is random, it still has the property that you need a large portion of the entire network to corrupt what's going on inside of any shard. But the system is still kind of very redundant and very secure.
That's brilliant. How hard is that to implement, and how hard is proof of stake to implement? Like on the technical level,
Yeah.
software level.
Proof of stake and sharding are both challenging. I'd say sharding is a bit more challenging. The reason is that proof of stake is kind of just a change to how the consensus layer works. Sharding does both that, but it's also a change to the networking layer. The reason is that sharding is kind of pointless if at the networking layer you still do what you do today, which is you kind of gossip everything, which means that if someone publishes something, every other node in the client hears it like from on the networking layer. And so instead we have to have kind of subnetworks and the ability to quickly switch between subnetworks and have those subnetworks talk to each other. And this is all doable, but it's a more complex architecture, and it's definitely the sort of thing that has not yet been done in cryptocurrency.
So most of the networking layer in cryptocurrency is you're shouting, you're like broadcasting
Yes.
messages, and this is more like ad hoc networks. Like
You're shouting within smaller groups.
smaller group, but you have like a bunch of subnet and
Exactly.
you have to switch between. Oh man, I'd love to see the. So it's a beautiful idea. So from a graph theoretic perspective, but just the software that like who's responsible? Is the Ethereum project, like the people involved, would they be implementing, like what's the actual, this is like legit software engineering. Who, like, how does that work? How do people collaborate, build that kind of project? Is this like almost like, is there a software engineering lead? Is there is it a legit, almost like large scale open source project?
There is, yeah. So we have someone named Danny Ryan on our team who's just been brilliant and great all around. And he is a kind of de facto kind of development coordinator, I guess. It's like you have to invent job titles for this stuff, right?
Yes.
The reason is that like we also have this unique kind of organizational structure where the Ethereum Foundation itself kind of does research in-house, but then the actual implementation is done by independent teams that are separate companies, and they're located all around the world in like fun places like Australia. And so you kind of just need a bunch of kind of almost nonstop cat herding to just keep getting these people to kind of talk to each other and kind of implement the spec, make sure that everyone agrees on kind of what's going on and kind of how to interpret different things.
So how far into the future are we from these two mechanisms in Ethereum 2.0? Like what's your sense of the timeline, keeping in mind the previous comment you made about the sort of general curse of software projects?
So Ethereum 2.0 is split into 3 phases. So phase 0 just creates a proof of stake network, and it's actually separate from kind of the proof of work network at the beginning, just to kind of give it time to grow and improve itself.
Do people get to choose? Sorry to interrupt. Do people get to choose, I guess, which
Yes, they get to
consensus
choose to move over if they want to. Then phase one adds sharding, but it only adds sharding of kind of data storage and not sharding of computation. And then after that, there is kind of the merger phase, which is where the kind of the accounts, kind of smart contracts, like all of the kind of activity on the existing ETH1 system just kind of gets cut and pasted into ETH2. And then the proof of work chain gets forgotten, and then all the things that were living there before just kind of continue living inside of the proof of stake system. So for timelines, phase zero has been kind of almost fully implemented. And now it's just a matter of a whole bunch of security auditing and testing. My own experience is that right now it feels like we're at about a phase comparable to when we were doing the original Ethereum launch, when we were maybe about 4 months away from launch.
But that's just a hunch. Then
That's just a hunch, yeah.
So how, it took like over a decade for people to move from Python 2 to Python 3. How do you see the move from like this phase zero of for different consensus mechanism? Do you see there being a drastic phase shift in people just kind of jumping to this better mechanism?
So in phase zero, I don't expect too many people to do much, because in phase zero and phase one, the new chain kind of deliberately doesn't have too much functionality turned on.
Right.
It's there just like if you want to be a proof of stake validator, you can get things started. If you want to store data for like, other blockchain applications, you can get started. But existing applications will largely keep living on ETH1. And then when the merger happens, then the merger is a operation that happens all at once. I mean, so that's kind of one of the benefits of a consensus system, that like on the one hand you have to coordinate the upgrade, but on the other hand the upgrade can be coordinated.
So what's Casper FFG, by the way?
Casper FFG is the consensus algorithm that we are using for the proof of stake.
Is there something interesting specific about Casper FFG, like some beautiful aspect of it that's
there is. So
mentioning?
Casper FFG combines together kind of two different schools of consensus algorithm design. So the general two different schools of this design are, right, one is kind of 50% fault tolerant but dependent on network synchrony. So 50% fault tolerant, but it can tolerate up to 50% of faults, but not more. But it depends on an assumption that all of the nodes can talk to each other within some kind of limited period of time. Like if I send a message, you'll receive it within a few seconds. And the second school is 33% fault tolerant, but safe under asynchrony, which means that like if we agree on something, then that thing is finalized. And even if the network goes horribly wonky the second after that thing is finalized, there's no way to revert that thing. And
that's fascinating how you would make that happen.
It's definitely quite clever. I'd recommend the Casper FFG paper. If you just search like archive, as in like ARXIV and Casper FFG,
that's
right
on archive. There. The paper's on archive.
Yeah.
Who are the authors?
Myself and Virgil Griffith.
That's awesome. I take a small tangent. This idea of just putting out white papers and putting them on archive and just putting them publicly, is that at the core? Is that a necessary component of cryptocurrency? Is that the tradition started with Satoshi Nakamoto? What do you make of it? Like, what do you make of the future of that kind of sharing of ideas?
I guess so, yeah. And it's definitely something that's kind of mandatory for crypto, because like crypto is all about making systems where you don't have to trust the operators to trust that the thing works. And so if anything behind how a system works is closed sourced, then that kind of kills the point. And so there is the kind of a sense in which the fundamental properties of the category of the thing we're trying to build just kind of forces openness. But also openness just has proven to be a really great way to collaborate. And then there's actually been a lot of kind of innovation and academic collaboration that's just kind of happened ad hoc in the crypto space the last few years. So like, for example, we have this forum called ETH Research. That's like ETHRESEAR and then .ch. And there we publish kind of just ideas in a form that's kind of half formal, like it's halfway in between, like it's a kind of a text write up, and you can have math in it, but it's often kind of much shorter than a paper.
Hmm.
And like, it turns out that the great majority of new ideas, like they're just kind of fairly small nuggets that you can explain in like 5 to 10 lines, and they don't really
They don't need the whole
yeah,
formality of a paper, right?
exactly. They don't require the kind of like 10 pages of and a filler. And so,
Introduction, conclusion is not needed.
yeah. And so instead, you just kind of publish the idea, and then people can go comment on it.
That's
And
brilliant.
yeah, no, this has been
So,
really great for us.
I think I interrupted you. Was there something else on Casper FFG that's
No, so
interesting?
just Casper FFG is just kind of combines together these two schools.
Yes.
And so basically, it creates this system where if you have more than 50% that are honest, then and you have network synchrony, then the thing kind of goes as a chain. But then if network synchrony fails, then kind of the last few blocks in the chain might kind of get replaced. But anything that was finalized by this kind of more asynchronous process gets like can't be reverted. And so you essentially get a kind of best of both worlds between those two models.
Okay, so I know what I'm doing tonight. I'm going to be reading the Casper FFG paper. Apologize for the romanticized question, but what to you are some or the most beautiful idea in the world of Ethereum? Just something surprising, something beautiful, something powerful.
Yeah, I mean, I think the fact that money can just emerge out of a database if enough people believe in it, I think, is definitely one of those things that's up there. Um, I think one of the things that I really love about Ethereum is also this concept of composability. So this is the idea that like if I build an application on top of Ethereum, then you can build an application that talks to my application, and you don't even need my permission. You don't even need to talk to me, right? So one really fun example of this is there was this kind of game on Ethereum called Crypto Kitties that
Mhm.
just involved kind of breeding digital cats,
Yes.
and someone else created a game called Crypto Dragons, where the way you play Crypto Dragons is you have a dragon and you have to feed it crypto kitties. um, and they just created the whole thing just like as an Ethereum contract that you would send these tokens that are defined by this other Ethereum contract. And for the interoperability to happen, like the projects don't really need to, like the teams don't really need to talk to each other. You just kind of interface with the existing program.
So it's arbitrarily composable in this kind of way. So you have different
Yeah.
different groups that could be working. So you could see it scaling to just outside of dragons and kitties. It could be you could build like entire ecosystems of software in
Yeah,
this kind
and
of way.
in the, I mean, especially in the decentralized finance space that's been popping up the last 2 years, there has been a huge amount of really interesting things happen as a result of this.
Is it a particular kind of like financial applications kind of thing?
Yeah, I mean, there's like stable coins, so this is kind of tokens that retain value equal to $1, but they're kind of backed by cryptocurrency. Then there's decentralized exchanges. So, when as far as the decentralized exchanges goes, there's this really interesting construction that has existed for about 1.5 years now called Uniswap. So what Uniswap is, it's a smart contract that holds balances of two tokens. We'll call them token A and token B. And it maintains an invariant that the balance of token A multiplied by the balance of token B has to equal the same value.
Mhm.
And so the way that you trade against a thing is basically like you have this kind of curve, like x times y equals k. And before you trade, it's at some points on the curve. After you trade, you just like pick some different any other points on the curve, and then whatever the delta x is, that's the amount of A tokens you provide. Whatever the delta y is, that's the amount of B tokens you get, or vice versa. And then kind of the slope at the current point on the curve kind of is the price. And so that just is the whole thing, and that just allows you to have this exchange for tokens, and even if there's very few participants, and the whole thing is just like so simple, and it's just very easy to set up, very easy to participate in, and it just provides so much value to people. So,
And the fundamental the distributed application infrastructure allows that somehow.
yes. So this is a smart contract meeting. This is all a computer program that's just running on
Got it.
Ethereum.
Smart contracts too are just fascinating.
They are.
Okay. Do you think cryptocurrency may become the main currency in the world one day? So, where do you think we're headed in terms of the role of currency, the structure, type of currency in the world?
I definitely expect fiat currencies to continue to exist and continue to be strong, and I definitely expect kind of fiat currencies to also digitize in their own way over the next couple of decades.
What's fiat currency, by the way?
Oh, just like things like US dollars and like dollars and euros and yen and these other things.
And they're sort of backed by governments.
Yes. But I also expect kind of cryptocurrencies to play this kind of important role in just making sure that people always have an alternative if fiat currencies start breaking. So like if you're in some kind of very high inflation place like Venezuela, for example, or if your country just kind of gets cut off cut off from other financial systems because of like something the banks do, like if there's even like some major trade disruption or something worse happens, then like cryptocurrencies are the sort of thing that just because of their kind of global neutrality, they're just kind of always there and you can keep using them.
It's interesting that you're quite humble about the possibilities of the future of cryptocurrency. You don't think there's a possible future where it becomes the main set of currency? Because it feels like fiat, it feels like the centralized control by governments of currency is limiting somehow. Maybe in my naive utopian view of the world.
It's definitely very possible. I mean, I think like for cryptocurrencies being the main form of value to kind of work well, like you do need to have some much more price stability than they have today. And I mean, there are now stable coins and there are kind of cryptocurrencies that try to be more stable than existing things like Bitcoin and Ether, but that just is, to me, the kind of the main challenge.
Do you think? Do you think that's a characteristic of this just being the early days? And it's such a young concept. 10 years is nothing in the history of money.
Yeah, and I think it's a combination of two things, right? One is it's still early days, but the other is a kind of more durable any kind of economic problem, which is that like demand for currency is volatile, right? Because of like recessions, booms, changes to technology, lots of things, and if people's demand for how much currency they want to hold changes. And if you have a currency that has a fixed supply, then the change in demand has to be entirely expressed as a change in value of the currency. And so what that means is that kind of the volatility of demand becomes entirely translated into volatility in kind of prices of things denominated in that currency. But if you have a currency where instead the supply can change, and so the supply can kind of go up when there's more demand, then you have the supply kind of absorbing more of that volatility, and so the price of the currency would absorb less of the volatility.
On that topic, so Bitcoin does have a limited supply, a specific fixed supply.
Yes.
What's the idea? And Ethereum doesn't, but can you clarify? Just on the comment you just made, is Ethereum qualify to the kind of currency that you're talking about and being flexible in the supply?
And it's a bit more flexible, but kind of the thing that you would really want is something that's kind of specifically flexible in response to how valuable the currency is. And I'd recommend to look at stable coins as well. So like things like DAI, for example. It's like
How do you spell that?
DAI.
And what's stable coins? Is it a type of cryptocurrency?
It is a type of cryptocurrency. It's a type of cryptocurrency that's issued by a smart contract, one of these Ethereum computer programs, that where the smart contract holds a bunch of ether, and then it basically like that people deposit, and then it issues DAI, and the reason why people deposit is because they want to kind of go high leverage on their ether, and so it kind of pairs these two sets of users, one that wants stability and one that kind of wants extra risk together with each other, and it basically creates or gives one set of participants a guarantee that they'll be that they have this asset that can be later converted back into ether, but like specifically at kind of the $1 rate.
And it has some kind of stabilizing network effects when they're
Yeah,
to
it
a
has
paired.
this. Yeah, it has many kinds of stabilizing mechanisms in it.
That's fascinating. Okay, this world is awesome technically.
Huh.
Just from a scientific perspective, it's an awesome world that I often don't see from an outsider's perspective. What I often see is kind of uh, maybe hype and a little bit, if I may say so, like charlatanism.
Hmm.
And you don't often see, at least from my outsider's perspective, the beautiful science of it and the
Yeah.
engineering of it.
Hmm.
Maybe is there a comment you can make of who to follow, how to learn about this world without being interrupted by the charlatans and the hype people in this space?
I think you do need to just know the specific kind of just people to follow. Like there's there's all the kind of the cryptographers and the researchers, and then there's just like even just the Ethereum research crew, like myself, like Dankrad, Danny, Justin, and of the other people, and then and of the academic cryptographers, and I came like before this today I was at Stanford, and Stanford has the Center for Blockchain Research, and of Dan Bonet, that's kind of really famous and great cryptographer, was running it, and there's a lot of other people there, and there's people working on like zero knowledge proofs, for example, and Zuko from Zcash is kind of one other person that I kind of respect. So I think if you follow the
And
technical
just
people,
crawl along that.
yeah, you just kind
Start
of
with the
crawl.
Ethereum group and then look at the academics, Debonet, and so on, and then
Yeah,
just cautiously expand the network of people you follow.
yeah, exactly. And like if someone seems too self promotional, then just
Yeah,
like
that's.
remove them.
Is there books that are so there's these white papers, and we just discussed
Yeah,
about ideas being condensed into really small parts.
there
Is there
are.
books that are emerging that are kind of good introductory material for
So for
crypto?
historical ones, and there's like Nathaniel Popper's Digital Gold, which is just about the history of Bitcoin. There's like one, and then Matthew Lysing announced that there's one about the history of Ethereum. For technical ones, and there's Andreas Antonopoulos as Mastering Ethereum.
Great. So let me ask you, sort of, sorry to pull back to the idea of governments and decentralized currency.
Hmm.
There's a tension between decentralization of currency and the power of nations,
Hmm.
the power of governments. What's your sense about that tension? Is there some rule for regulation of currency? Yeah. Is there like, is government the enemy of digital currency, of distributed currency, or can they be like cautious friends?
I mean, I think like the one thing that people forget is that it's clearly not entirely an enemy, because I think if there hadn't been so much government regulation on kind of centralized issuing centralized digital currencies, then we'd be seeing things, people like Google and Facebook and Twitter just kind of issuing them left and right. And then like if that was the case, then decentralized currencies would still appeal to some people, but they definitely would appeal to less people than today. So even in that sense, I think it's like clearly been kind of more of a just kind of set the stage for the kind of the existence as of the sector in some ways, but also, and I think some of both. Like there's definitely things that governments kind of can do, in some cases have done to hurt the spread of and of growth of blockchains. There's things that they've done to help, and they've in some cases definitely done a good job of kind of going after fraudulent projects and of going after some of the projects that have some of the kind of craziest and most misleading marketing. There's also the possibility that governments will end up using blockchains for a lot of different things. Like, governments, yeah, I mean, they do a lot more than just regulating, right? Like, there's
Yes.
also, like, they have the kind of identity records, and they have kind of like property registries, even just their own currency is like secure, like lots of different kind of things that they're operating, and there's even blockchain applications in a lot of those.
Yeah, and they can, they can leverage technology to do a lot of good for our societies.
Hmm.
It is a little unfortunate that governments often lag behind
Hmm.
in terms of their acceptance and leverage of technology. If you look at the autonomous vehicle space, AI in general, they're a few years behind,
Hmm.
and it'd be nice to help them catch up. That's a always ongoing problem. You met Vladimir Putin
Hmm.
to discuss decentralized currency. You're born in the where were you born?
Kolomna. It's a city about 115 kilometers south of Moscow.
In Russia.
Yes.
Yeah, I grew up in Moscow. I mean, that's Vladimir Putin
Mm.
is a central figure in this part of the world. So, what was that like
Uh,
meeting him? What was that experience like?
he's taller in photos than in person. Um,
Yeah, he's
uh, um,
yeah, that's right. He's 5'7", I think, five
mhm.
eight maybe.
Yeah, and that's unfortunately we didn't actually kind of have too much of a chance to talk to him. Like I managed to see him for about 1 minute at the end of this meeting, and I did get a chance to see a lot, like some of the other kind of government ministers, and like he recommended some, and some of them are actually kind of interested in trying to use like blockchains to like for various government use cases to kind of limit corruption and other things. And I have like it's hard to tell from one conversation kind of what things are genuine and what things are just like, oh, blockchain is cool, let's do blockchain.
Right.
Mm.
But when I listen to like Barack Obama talk about artificial intelligence,
Mm.
there's certain things I hear where
Mm.
okay, so he might not be an expert in AI, but he like actually studied it carefully enough to think about it. Like he
Mhm.
internal like even if it's just reading a Wikipedia page,
Huh.
like he really thought about what this technology means. Did you get a sense that Putin or some of the ministers like thought about blockchain, like thought about the fundamentals of technology, or like understand it intuitively, or are they too old school to try to grasp it?
Some are old school, some are more new school. It depends. It's definitely like depends on who you talk to.
I mean, that's an open question for me with Putin because Putin
Hmm.
has said
Yeah. I don't
some
know. And
stuff
as I
about
said, I've
AI,
only talked to him for about 1 minute, so
but sometimes you can pick up sort of
uh,
insights. As a quick comment, there are about maybe you can correct me on this, but there are about 3,000 cryptocurrencies being actively traded.
yes.
And Ethereum is one of a lot of people believe that Ethereum will be the main cryptocurrency. I think Bitcoin is currently still the main cryptocurrency,
Hmm.
but Ethereum very likely might become the main one. Is this kind of diversity good in the crypto world? Do you see it sticking
Hmm.
around? Should there be a winner? Like, should there be some consensus globally around Bitcoin or around Ethereum? Like, what's your sense?
I definitely think the diversity is good, and I definitely think also that there's probably too many people trying to make separate blockchains kind of right now.
Yeah,
The number should definitely be greater than one, and probably greater than two or even five.
but not three
But
thousand.
not 3,000, yeah, and also not even like 40 high quality platforms that try to do the same thing. Yeah, there's definitely this range from just like one person who just like wrongly thinks that you can create a cryptocurrency in like 12 hours and like doesn't even think about kind of the community aspects of maintaining it, going to people actually trying but only creating a really tiny one, to like scammers, to people like making something that's actually successful. And then there's a lot of different categories of blockchain and of project in terms of what it's trying to do and what applications it's for. And I think the experimentation is definitely healthy.
if you look at the two worlds, there might be a little bit disjoints, but the distributed applications, cryptocurrency, and then the world of artificial intelligence.
Hmm.
Do you see there's some overlap between these worlds that both worry about centralized control? Is there some
Hmm.
overlap that's interesting that you think about? Do you think about AI much?
Yeah, and I think definitely kind of thought about things like like the AI kind of control problems and alignment problems and all of those
Do
things.
you worry about the existential threat of AI?
It's definitely one of the things I worry about. And I think block there's a lot of kind of common challenges because in both cases what you're ultimately trying to do is you're trying to kind of get a simple system to direct a more complex system. Like in the case of these strong AIs, the idea would be that the simple system is people and the complex system is, well, whatever thing the people end up kind of unleashing on the universe that'll hopefully be a great thing. And in the case of blockchains, and of the complex, well, the simple thing is the algorithm, which is a piece of static and fully open source code, and the more complex thing is just all of the different possible kind of human actors and of the strategies that they might end up used to participate in the network. And,
Do you think about your own mortality, like what you hope to
um,
accomplish in your life in the
oh,
context?
I definitely think about ending my own mortality.
So that's if I gave you the option to live forever, would you?
Depends a lot on what the fine print is. But I mean, if it's one of those things where I'm gonna be kind of like floating through empty space for 10 to the 75 years, then no. If it's forever worth of and of having a fulfilling life with and of meaning like with friends to spend the time with kind of meaningful challenges to explore and kind of interesting things to be working on, then I think absolutely. Mm.
That's beautifully put. Live forever, but you'd have to check the fine print.
Mm.
I think there's no better way to end it. Vitalik, thank you so much for talking to us. So exciting to follow your work
Well,
from a
thank you.
distance. And thank you for creating a revolutionary idea and sticking with it and building it out and
Mhm.
doing some incredible engineering work. And thanks for talking today.
Yeah, thank you.
Thanks for listening to this conversation with Vitalik Buterin. And thank you to our sponsors, ExpressVPN and Masterclass. Please consider supporting the podcast by signing up to Masterclass at masterclass.com/Lex and getting ExpressVPN at expressvpn.com/LexPod. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars on Apple Podcast, support it on Patreon, or simply connect with me on Twitter at Lex Friedman. And now, let me leave you with some words from Vitalik Buterin. The thing that I often ask startups on top of Ethereum is, can you please tell me why using Ethereum blockchain is better than using Excel? And if they can come up with a good answer, that's when you know you got something really interesting. Thank you for listening and hope to see you next time.